Hey everybody, welcome to the Good System Speaker Series. Just a reminder, we'll be recording this session for viewing later, and also closed captioning is enabled. I'm Ken Fleischman, I'm the founding chair of Good Systems UT Grand Challenge, and I'm really honored and delighted to get to introduce our speaker for today, Dr. Ed Cutrell. Dr. Cutrell is a senior principal research manager at Microsoft Research, where he manages the MSR Ability Group, exploring computing for disability, accessibility, and inclusive design. He also holds an appointment as an affiliate professor in the Information School at the University of Washington. He received his bachelor's in psychology and cognitive science from Rice, and he went on to study cognitive neuropsychology at University of Oregon, where he received his PhD in 1999. He's been working in the field of HCI pretty much ever since. So I also, on a personal note, had the distinct pleasure and honor of getting to collaborate with Ed on the Microsoft Ability Initiative, which was a partnership between Microsoft Research and UT Austin, specifically the School of Information, where I am a professor. It's been really wonderful getting to collaborate with Ed on that project, and I know that a lot of our Good Systems researchers will really enjoy and get to benefit from learning more about the exciting work that Ed and his colleagues are doing at Microsoft Research. So Ed's going to be talking about AI, MR, and inclusion, challenges and innovations in assistive technology. So we're so delighted to have you here. If everyone could please join me in giving a virtual round of applause for Dr. Ed Cutrell.
All right, well, let me get this going. I can make sure that shared sound, all that is correct. And hopefully everybody can see this okay. So it is a real pleasure to be here. And thank you so much for that kind introduction, Ken. That was really very nice. And I'm just excited to be here chatting with you guys today about some of the work that we've been up to, really looking at the intersection of artificial intelligence, mixed reality, sometimes people call this XR or extended reality, but then thinking about how do we make this inclusive. So to start this off, I want to begin by walking through a little bit about what is accessibility. And at a very basic level, the question is, how do we think about the way accessibility fits into design? So accessibility fundamentally is how we let people with a variety of different abilities interact with the world around us. And so this is for sensory disabilities, we have vision, hearing, other kinds of things, cognitive disabilities, and then mobility and the way we actually have movement and move around. Now, it's important to think about the way our conceptions of disability have changed over time. In 1980, the WHO referred to disability as any restriction or lack of ability resulting from an impairment to perform an activity in the manner or within the range considered normal for a human being. And let's contrast that with the way that it's currently defined as not just a health problem, but a complex phenomenon reflecting the interaction between features of a person's body and features of the society in which he or she lives. So the point here is that disability is not really about being out of the normal range, but it's a mismatch between the capabilities of somebody and then the capability of the product or the environment in which they are. And that's an important point because the more mobile a technology is, or the more contexts in which we use it, the more frequent the moments of disability arise for everyone to interact. So the big point here is that disability is not about a health condition, but it's really about this mismatch between how a human is interacting and what is the ways in which they can access those things. It's often useful to think about disability along an axis of short-term and long-term. And you can think about it this way, like a congenital disability is clearly a long-term disability. You're born with it and you have that. You may acquire that disability later in life. And so this is like an older person. They're starting to lose the ability to walk easily, so they need an assistant to it. there's a temporary disability. I broke my leg. And so I need this like rolling device to help me get around. But, you know, eventually my leg is healed and I'm able to start walking normally. And then there's things that are situational impairments. I'm pushing kids around in a stroller. And all of these are served by an example accessible design of a curb cut, which allows the people from the long-term disability all the way to situational impairment to manage. Another way to think about this is to think about this as the person spectrum. When you design a solution optimized for someone who experiences a disability on a permanent basis, lots of other people can benefit. And so like in this example here, if you think about captioning was really designed for people who are hard of hearing or deaf. But it turns out that someone reading in an airport, when they're looking at the television screen, also finds that really useful. But it's also the case that a lot of studies have shown that captions are useful in teaching children to read. And so the idea is that we can use the persona spectrum of this range of things to understand the mismatches and motivations across permanent, temporary, and situational scenarios, and then design accordingly. All right, so that's the little primer in accessibility. And I want to move now into some thinking about virtual reality, and then we'll move into some stuff around augmented reality and artificial intelligence. So commercial VR systems are now becoming more and more commonplace. Improved graphics and hardware are making these VR systems viable, but we still don't see really much in the way of accessibility. And in fact, this has come up recently in a number of different public settings. A couple of years ago, Scientific American had this thing, virtual reality has an accessibility problem. Just last week in Wired, there's VR is here to stay. It's time to make it accessible. And there are more and more of these kinds of public observations about the interaction between accessibility and VR, which right now is pretty much nothing. Back in 2019, my group, some people associated with my group posted this paper that's called Accessible by Design, in which we really tried to break down what would be involved in making virtual reality accessible. And so this was published at ISMAR 2019. That's the International Symposium on Mixed and Augmented Reality. And in this paper, we highlighted 5 key areas of focus that we really needed to be thinking about for virtual reality. The first of these is content accessibility. And this really has to do with what are you showing in the information itself. You have interaction accessibility, the way in which you interact with the device. The device accessibility is the actual hardware itself and whether people can actually use that hardware. We've also got really interesting questions about inclusive representations. How are people within virtual reality displayed to other people? What is their actual representation within that space? And then finally, application diversity, which is the range of the kinds of applications which may be relevant for people with various kinds of disabilities. Today, I'm going to highlight 3 of these, some projects that maybe address 3 of these different areas. And the first of these is in content accessibility. Now, if we think about, let's dig a little deeper into what that means. So media forms have a variety of standards to make content accessible. And these include things like captions to make audio and videos accessible to people who are deaf or hard of hearing, alt text to make images accessible for people who are blind or low vision. But the problem is that VR really lacks any of these agreed upon standards. There is no WCAG equivalent for VR. WCAG are the set of standards that are associated for the World Wide Web. Now, so we need to figure out sort of like what kinds of metadata is appropriate or necessary for providing these kinds of accessibility. And then we need to be able to create standards for that. And ideally, then be able to apply various kinds of accessibility options post hoc. Now, the kinds of post hoc things I'm thinking about here are things like captions for audio rendered in the environment, or inverting colors or magnifying content or other things like that. And so to that end, we tried to think about a set of things that might help people out for this content accessibility. And that was in a project called Seeing VR. We published this a few years ago, and essentially this was a set of 14 tools for Unity VR that enhance the VR experiences for people with low vision. This is not for blind folks. These are really people who just have trouble seeing that is not correctable. Now, 9 of these tools are post hoc. They just run in runtime. So the application developers don't have to care about them at all. And then 5 of them require a little bit of developer provided metadata. So I'm going to try to play a video here to show you a little bit of this. I'm going to stop the video early. If you're interested, you can find this on YouTube. It's easy enough to look. You just look up Seeing VR and you can find the whole video. But I'm going to play probably the first couple of minutes of it to give you a feeling for the kinds of tools we developed.
Seeing VR, a set of tools to make virtual reality more accessible to people with low vision. Current VR technology is vision dominant, and most VR scenes are designed by only considering the visual abilities of fully sighted users. 217 million people worldwide have low vision, moderate to severe visual impairments that fall short of complete blindness, but that cannot be corrected fully by glasses. Virtual reality is often not accessible for people with low vision. We designed Seeing VR, a set of 14 low vision tools that can be applied to a VR application as an overlay in runtime and enhance its scenes by providing both visual and audio augmentations. With Seeing VR, a user can select, adjust, and combine different tools to augment the VR scenes according to their preferences. We implemented 9 of these tools as an extension that plugs into available VR applications without requiring any changes from the producer or developer. We also implemented 5 additional tools for VR developers to integrate low vision support into the design process of their applications. We begin by demonstrating the tools for existing apps and then show the tools for empowering developers. Our magnification lens simulates the effect of a magnifier attached to the center of the user's visual field to help users see details or things that are far away. Users can adjust the magnification level based on their needs. To reduce the dramatic change that a magnifier brings, we designed a bifocal lens by adding a small rectangular-shaped magnifier at the bottom of the user's visual field. While looking at the magnifier part to see details, the user can still see the original virtual scene by looking through other areas of their visual field. The user can adjust the position of the bifocal lens. Since people with low vision have different light sensitivities, we provide a brightness lens, allowing the user to adjust the brightness of the scene. For people with low contrast sensitivity, we provide a contrast lens to help increase the contrast of VR scenes. This is edge enhancement. We add edges to the whole virtual scene based on the depth and surface normal change. With this tool, a user with low vision can better distinguish different objects in a low contrast scene. Users can adjust the color of the edges based on the color of the original scene and their preference. Peripheral remapping is designed for people with peripheral vision loss. We overlay the contours of a minified view of a wide field over the center of the user's original vision, providing information that was formerly in their peripheral vision. The user can adjust the color and position of the overlay based on their needs. When text in a virtual scene has low contrast with the background, our text augmentation tool automatically changes the text color to be the inverted color of the background. The user can also decide whether to make the text bold and how much to increase the font size. When visual augmentation is not sufficient, our text-to-speech tool provides audio augmentation. With this tool, the user can use a laser attached to the controller to point to a piece of text in the scene, and our tool can automatically read it aloud.
All right, I'm going to stop there, but you get an idea of kind of what that's about. And the idea here is really trying to make that content accessible. But even if the content is accessible, the device itself may have problems because the VR devices make a number of assumptions about users' abilities. For example, a VR headset presumes that a user can equip the VR headsets independently, and they have the range of motion to reach behind their head, to adjust the knob or tighten or loosen their VR headsets. And they also often assume that they have the strength in their neck and a range of movement in their head to view scenes in VR by looking around. So for people with limited or restricted head movement, viewing scenes in VR can be really hard. So to address this, we did a series of interviews with people with various mobility impairments to try to understand how that device accessibility might work. What strategies have people had that might help them overcome some of these accessibility barriers? Now, in this paper, we really identified 7 main barriers. So the first of these is setting up a VR system to begin with. The next is putting on and taking off an HMD. We also looked at adjusting the head strap, cable management. If you're in a wheelchair or in a power chair, that cable management can really turn into a nightmare. Accessible buttons. The different buttons in a VR systems often include requirement of fine motor control on your fingers, manipulating dual motion controllers, and so having both of the independent motion there, and then finally maintaining the view of the controllers while you're trying to interact. I want to talk in particular about this notion of interaction accessibility because it addresses this question about the physical as well. So in interaction, assuming that you've got these independent controllers, increasing the fidelity of the VR input and output can often amplify these differences of how we interact with this stuff. So an example of this from that study that I was describing, which we interviewed folks, we got this quote from a person when he was talking about interacting with the 2 different motion controllers. And he says, "I'm not sure that it would be possible for me to do them simultaneously. If I had to, I could do it one-handed, but I have to do both at the same time. So that's just not going to work." So let me give you an example of the kind of thing we're talking about here. So this is an example game that uses bimanual input. I'm just going to play a brief little piece of this.
So you want to do a half little grip on your trigger, and that'll keep the grip stamina fine. And then every now and again, you just press and hold the grip button and shake your hand, and you'll re-chalk your hands, which will help with your grip as well. Where do we want to go? Oh my God, just look at that.
Okay, enough of that. So basically, hopefully it's really obvious here that this notion of bimanual input is really important within a lot of VR examples, but it's also could be really problematic. And so we did a project trying to understand how to allow people to control bimanual input interfaces when they only have one hand available. And I want to bring up here, this is Momona Yamagami. This is a student that we worked with for this project. I'm bringing her up here basically because she's looking for a job in the near future and she wants to move to Texas. And so all of you out there that you're paying attention, maybe you could reach out to her. But in this project, we looked at particularly a framework for bimanual actions, which was based on some work by Yves Guillard back in the 80s. And he mapped out this general framework for the way that 2 hands interact. So on the one hand, you've got a case, pardon the pun, where the 2 hands play the same role. They're symmetric and in phase. This would be like jumping a rope. Symmetric and out of phase, climbing a ladder, where they're doing the same thing, but they're out of phase from each other. There's asymmetric coordinated. So that's like holding a piece of fruit and cutting it with a knife. And then there's asymmetric uncoordinated. And this would be an example of I've got the shield and I've got the sword. And they're doing 2 different things at the same time. So in this work, we really looked at a set of these, but I'm going to show you an example of looking at some of the issues and the problems associated with this symmetric out of phase example. And this is very much like what we just saw, the person climbing on the climbing game. So when we start looking at this notion of trying to create something that is an accessible technique for this, we move from something that has less autonomy to more autonomy. So in less autonomy, we could automatically perform the task for the person. Now that's not a lot of fun, but at least they're able to do it. We can infer output of the two hands given input from the one hand. So we just make some assumptions about what the other hand has to do. And then finally, we use some other alternative input. For instance, maybe we could use eye gaze or the position of the headset to provide information about what that second hand would be doing. Now, if we're inferring the virtual hand, we're essentially going to mimic the direction, speed, distance, et cetera, of the one hand, and then snap the virtual hand that's closest to the next interactional object. Now, this is great because it is less fatigue and effort, it's automatic, and you can perform these movements simultaneously. But the problem here is that the user has less control. And so we're removing autonomy from the person, and we're just assuming things about what it is they want to do next. An alternative would be to use something like the gaze position or the head position. Now, this allows more autonomy and control. You can do things simultaneously, for instance. You could do both hands at the same time because one hand is doing one thing and the head and gaze position is managing the other. But the problem is that we need the same degrees of freedom as the hand. And it can also have really significant issues with overloading. You're trying to look around at the same time you're trying to control the activity. And it might not be accessible for some users. There are a lot of different ways to implement this, but I'm going to show you one of the ways that we did this to just give an example of what's possible. So here's Mamona demonstrating a climbing game using this alternative input. You can see that her hand and her head are moving independently. She's climbing with the one hand, and then she's using her gaze to direct the next. All right, so hopefully I've demonstrated here some ways in which we can think about both the needs for creating accessible input for VR, but also some of the ways in which we can go about doing that. It's really entirely in our power to do it, but we just have to be a little bit creative and then actually do the work to create this kind of inclusion. I want to move now into augmented reality. And in particular, I want to talk a little bit about Soundscape. So Soundscape is an app that's available on iOS today that helps people understand the real-time location of things in the world around them via spatial audio. So this is audio augmented reality. So I'm going to show you a video of Amos. He's one of the principals on the Soundscape team, and he's demonstrating the use of Soundscape out and about in the world. Now, I want to point out that Zoom flattens the stereo audio. So even though he says you'll hear it off and to the left and to the right, et cetera, in Zoom, you won't really be able to hear that. But if you were to look for this on YouTube, you'll get the audio sound and you can actually hear this in reality. Or better yet, if you have an iPhone, you can download the app and experience it for yourself. So here is Amos talking about Soundscape.
Hello and welcome. We are going to demonstrate how I use Soundscape. I have my friend Emily here with me.
Hi there.
And my guide dog Trevor. You're going to hear and experience Soundscape in the same way that I do through these headsets. So let's go.
Facing north along 101st Avenue South.
So Emily, where should we go?
I heard there's a place called Local Burger nearby. Would you like to try it?
Let's do it. I'll set a beacon to it. Now I can hear the beacon over in front of us and to our right. That's where the Local Burger is.
Excellent. That beacon's really helpful as I can't see past these trees.
Fantastic. So let's go there.
All right.
Instead of step-by-step instructions, Soundscape lets me hear where the destination is so I can make my way there.
Main Street.
We're coming up to an intersection here.
Goes right. Crossing.
Here's the crossing. Listen to the traffic. We're safe to cross?
All right, and it's safe to cross.
Franz chocolates. Hey, here's Franz chocolate over there.
Oh, perfect. We should set a marker there on our way back.
Now I can hear the beacon loud and clear on my right, so we'll turn right.
Facing north along
and
Main
here
Street.
it comes right in front of us, so we know we're walking straight towards it.
Forum Plaza.
On Main Street and straight
Castle
towards the
Rear late in the
beacon.
day.
We're going to start hearing it coming on our left as we get close to the local burger.
Joseph Jewellery. Gilbert's on Main.
And
Beacon close by.
I can see the door.
here we are. Fantastic. Emily, thank you.
Thank you.
And thank you for listening.
All right, so a key thing to note about Soundscape is how it keeps the user immersed in the world. Objects are presented in real time in stable locations in space relative to the user as they move around, and they're presented in egocentric coordinates, and that's compared with allocentric coordinates like a map. So the idea here is that you hear it relative to where your head is and where you are. So Soundscape is not intended to be like a turn-by-turn set of navigation, but rather to give you ambient awareness of what's around you. It's also, because it has this idea of being able to create beacons, it's been used in adaptive sports. So things like kayaking, orienteering, and it's another great example of inclusive design that solves a problem for people who are blind, but it may provide benefits for any pedestrian. I know that when I use Soundscape personally, it's really interesting to be able to get that sense of where is the stuff around me without having to keep pulling my phone out, look at it, understand what's going on. I actually know where the thing is, and I hear it placed in space as a virtual object. All right, I'm going to show you another app here, which is called Seeing AI. And now we're moving out of the augmented reality and the VR reality into artificial intelligence. Now, Seeing AI is an app that's been out for a number of years. You can, again, download this from the App Store on iOS. And essentially what this is it's a talking camera app. And it's got a variety of different channels in the app. It's got like sort of real-time text. It's got people, scenes, handwriting. It's used by tens of thousands of users every day. And it allows people to use some of the cutting edge technologies that we have in computer vision to then provide some of this information for blind and low vision people. This is moving from right now a more of a static kind of thing. You can think of it as a Swiss Army knife. And we're actually now in the next months going to be looking at introducing some more augmented reality experiences of real-time interaction in the environment around you. So as you're moving through space, how do I help people understand what's around you? So keep an eye out on that. Happy to answer more questions about this, but I want to mention this because it leaves a nice segue into the last little section that I want to talk about today. And that's some work that we've done in the past few years called Peoplelens. So the Peoplelens is an AI system that helps people with mixed visual abilities interact with each other. And it helps people who are blind or low vision to understand in real time who and where the people are around them. So it enables people with vision to understand that they've been seen by the system and can then initiate interaction. So I have a few videos on this that'll help sort of unpack this. And then I want to talk a little bit about both the technology as well as some of the ethics and the design issues that we've had in dealing with ethical AI systems in augmented reality. Okay, first off, I need to apologize for the people who are watching this on recording right now, because that last video we're not able to share in recording. Basically, the kid who is there, his family has asked us not to allow that to be out in the public generally, but they were okay for us to show it sort of on a one-off basis. So apologies there. But let me talk to you a little bit about the Peoplelens itself. We've seen a particular potential of this technology for young people, as illustrated in that last piece. And so we've developed a curriculum, including a set of activities and games for helping children learn how to establish and direct their social attention. And so on this slide, you can see a variety of these papers that we've written that sort of unpack a little bit about different pieces of this technology. But I want to show you a video now of a student playing a game. in which he's controlling the activity of peers by the means of directed spatial attention. Now, in this case, the child that is wearing the device was born blind and has had a lot of trouble generally orienting to people around him. And you can watch how the game helps him to start to create some kind of control over the people around them.
Elric. The Peoplelens creates a map of people around the user. It identifies them and remembers where they are so that when the user turns towards them, they will hear a name.
Elric. Amy.
Here, Lucas is using this information to direct the game with his attention.
Elric. Amy. Elric.
The Peoplelens can also provide sounds to help Lucas look directly towards someone's face.
Elric.
With the Peoplelens and the companion scheme of work, children who are born blind can experience directing their own and others' attention, teaching them new skills and creating exciting opportunities for shared play.
All right, there are 4 algorithms underpinning this system. We have a pose model that knows the location and the position of people. There's an ID model that actually recognizes the people and identifies them. We have a tracking algorithm that maintains the world state as people move around. And then we have an algorithm to calculate the gaze direction of the people that are detected. Now, often people zero in on the pose and ID models as really suspect for any kind of ethical AI review. And if you think about it, most research in ethical AI focuses on the fundamental algorithms and the models individually, rather than on the whole system or the experience for people. So what I want to do today is to talk a little bit about using this as a case study of the Peoplelens to argue why it's so important to consider the whole system and not just assess the individual algorithms. So a big question here is, what about the bystanders? So it's clear in this case that we're potentially creating a really powerful tool for inclusion for TH. But what about TH's classmates? What about children on protected register or other people in the room? Now, there's a value tension here in which achieving a benefit for one person may cause harm to another. Now, often value tensions are seen as a spectrum where more for one person means less for another. So think of it as a zero-sum game. There's usually a spectrum of game privacy and inclusion. But we kind of think that it's maybe better to look at this in 2 dimensions. So the question here is, how can we increase both privacy and inclusion so that we're moving ourselves into the upper right-hand corner of this for more privacy and more inclusion? So if you state this as a design question, the question is, how can we create technology that forefronts inclusion but is considerate of harms that could result from the misuse of the captured data? So let me share with you a video of some of the approaches we took to ensure a balanced experience between a user and their communication partners. So here's Cecily, who's one of the leads on this project, talks about one of the features we developed for identifying a familiar stranger. So the familiar stranger in this situation is someone that you may interact with repeatedly, but you don't really know. So you can think of a bus driver or a sales clerk at a store. For example, one of our informants early on talked about an experience working with a hotel clerk to help them track down some lost luggage. There was one clerk that they had worked with repeatedly, and every time they would come down to the front to sort of like try to check up on it, it was important that they identified that person because they didn't want to walk through the whole history of everything with whoever happened to be standing behind the register. So they needed to find that person, but they didn't know their name. It wasn't really important. It just was that person. So let me walk through, let Cecily talk about this a little bit.
Throughout this process, our multidisciplinary team also had to grapple with the value tension of inclusion versus privacy. We'd like to share with you today our thinking on how we addressed this value tension for the familiar stranger feature. Our solution included both experience, technical, and social considerations. From an experience perspective, we decided to only keep a hash of the image, similar to photo-DNA, without any time or location data. However, this generates challenges of the user experience in how we present the familiar stranger to the user. We address this by labeling a familiar stranger with an animal name.
Lion.
This gives a singular identity to a familiar stranger, but avoids the need to capture time and location data that could be misused by a malicious actor. Thinking technically, we took a hint from human memory, forgetting any familiar stranger not seen within a 2-week period. However, we did not want to timestamp the data to determine an expiry date. Instead, we created a hash that timed people out over a period of 1.5 to 2.5 weeks. We then considered how bystanders could play a more active role in managing their own privacy. We developed an external interface which used an LED light band to show the person in closest communication distance and most likely to be identified next. As identification only happens when the user looks directly at someone, this provides an opportunity for the bystander to make a choice about whether they want to be seen. There are also a few ideas that user research helped us discard. We had originally thought to ask for consent from all bystanders for the familiar stranger feature. However, we realized that this would mean that people had to forefront their disability. We would have created a technology that labeled users as disabled, rather than creating a technology that made an inclusive society. Combining this experience approach, the technical approach of a data expiry, along with our social considerations, we feel that we created a technology that supports inclusion but doesn't disproportionately impact those who are bystanders.
So I'd like to return to the 3 elements mentioned in the video here. We have the social, the technical, and interaction. In the social side, the question is, could your users resolve the value tension through social understanding or interaction that comes from just a better understanding of the system or different interaction techniques? On a technical side, could you take a different approach to your system architecture algorithms or to data to resolve the issue? And then from an experience perspective, could you provide your user a different experience, varying technical or data requirements as a result of that? By having these sort of multiple handles or levers that you can pull, this allows you to adjust the value tension for a value tension that emphasizes not just the technical elements of the system or not just what the social bit is, but we can create these all together to create a balanced system that maybe can start to think about teasing apart the ethical experiences across these different pieces. Now, in particular, I want to note how the technical and interaction issues interact. So often when you change the technical requirements, this also requires a change to the experience itself. So by considering what's required for a good experience up front, we can often shift what the technical requirements are. Now, granted, this can often be easier said than done, but perhaps the biggest challenge is this continuing tech culture that separates out the design and the technology development, and it only puts them together at the very end. In this example, these 2 disciplines need to be working together from the start so that you make sure that you get the right and the most balanced experience that you can get, both between the experience and with the technical requirements. This does require a little bit of a change in the culture of the tech industry and sort of how we work with engineers and designers. But I really believe this is a critical thing in creating these more ethical and better experiences for everybody. So finally, I want to call out the role of social negotiation. And this is a really important point for this topic in particular, because as people, we socially negotiate our way through the day. Do you step aside for a person running for a train, or do we keep a safe path? The choice you make there depends on the context of the culture and the mood of the day. But our approach to ethical technologies is usually to take this opportunity away from people. We choose for you what you're allowed to do with the technology. And I don't think this has to be the case. For example, with the Peoplelens, communication partners can make an active choice of whether to be seen or not through the external display that indicates the system state. Now, perhaps there's an assumption that normal people can't understand the complexities of machine learning, but I think that that misses the point here. If we focus on system behavior rather than the algorithms, we can actively support the bystander interaction. And so this should become one of the primary tools we use to empower people to make in the moment choices about how they interact with the world and with the AI systems around them. So I want to close here and make sure we have enough time to some questions here. But if we're able to assess how systems help to make us super at being human, grounding assessment in the whole system, whether it's a social, business ecosystem, then we're starting from the right perspective to use the tools that we have to make consistently ethical experiences that open up more experiences to more people. That is, to make truly successful human AI partnerships, they don't make people superhuman. It just makes them super at being human. And so with that, I want to close, leave some time for talking, any questions you may have, and I'll leave it there.
Thank you so much, Dr. Cutrell. We really appreciate you sharing your insights with us today. And we'd like to open it up for any questions. So if you'd like to drop your question in the chat, please go ahead and do that and we'll read it out loud, or we will call on you if you would like to raise your hand to unmute and ask your question. And I do see a couple of raised hands now. Start with Stephen Slota.
Hi, great talk, really interesting technology, really interesting applications there. I love what you guys have been doing. My question has to do with the reach of these approaches and these technologies. I guess more specifically, it would be, are you disseminating best practices that kind of generalize from your learning experiences here, or making things that can be packaged and used at a broader scale? I really want to see this in a larger population. So I'm wondering how long we have to wait until these technologies are available.
The answer is a bit different for different technologies. But the fundamental answer is yes. To the extent possible, we are disseminating as widely as possible. In the talk here, I included a lot of publications that we've done. If you go onto my website, you can see a lot of that. Those are just academic publications and they're available for everybody to see. The Seeing VR, for example, is open source. So you can just go to GitHub, you can download that, you can run it, see how it works. We're also trying very hard to get these into some fundamental bits and pieces within Microsoft. Obviously, we can't control what Unity does or Unreal or Meta or anybody else, but we can at least start to bring these out. Part of that for us is also active engagement in organizations like XR Access, which is an organization that's specifically trying to create awareness and exchange best practices in the space for mixed reality and accessibility. As I mentioned in the talk, we're still really early days here, and there are no consortiums or anything else to sort of create standards on any of this stuff. So kind of the best we can do at this point is just throw this stuff out there and say, hey, look, first off, make a lot of noise that this is important. Within our company, we can try to get the products to start creating these things and to lead by example that way. And then finally, via publications. And beyond that, we just keep trying to shake the trees and make it happen. One good thing that we have going for us, at least within the US and in some parts of Europe, is legislation that requires accessibility. And so this creates a bit of a burden on anyone who's producing these commercially to actually basically comply with creating accessibility. That's a big stick on the part of the government. Now, the government has to be willing to push that, but at least with large companies like Microsoft, we're very, very attentive to that, let's just say, because that can be the difference between enormous sales as well. If you don't actually meet some of these requirements, you don't get to sell to a lot of really, really big customers. So I don't know if that answers your full questions, but that's sort of some of the expanse of some of that.
Definitely does. Thank you. It's great to see such innovation in this space. It's really an area of pressing concern. Thank you so much.
Thank you. I see another question here, and forgive me if I mispronounce your name, Hira.
Yeah, it's Hira, but you got it right. This was an amazing technology, and you ended it with a great quote. I literally just put it on a sticky note on my desktop. But so my question is more about, what do you think is next for products like these? I mean, it's very important to, yes, start a conversation, which I'm very glad is happening now. But what do you picture next for such technologies? Do you maybe go to other disabilities, or?
I would say that I like to think about this not on a disability by disability basis, but more as just a capability basis. And so, we start with some of these individual disabilities, but then you very quickly learn how they interact across. So for instance, some of the things that we've developed for blind and low vision folks actually turn out to be really important for neurodiverse folks as they're interacting. You can imagine in the case of meetings context, for instance, people who are neurodiverse often get overloaded very quickly. And so they may turn off their video or turn off information that then, if you can provide information by secondary or other means to help them keep track of what's going on in there, or maybe keep track of important social cues, that actually turns out to be important across these other kinds of areas. So I would say that's one point, and that's maybe aside from your real question, which is, what is next? And fundamentally, it's just to push hard on this in a variety of ways. For us, as I said, we're still fairly early days in particularly mixed reality. This is true in AI more generally, but in mixed reality, we don't know what it means to create a virtual reality experience that's actually usable by somebody who's blind. I have not seen anyone create such an experience. We're playing with it, we're investigating it actively, but I don't know what that would be right now. But we're starting to get a hint about that. And we're starting to be able, things like some of these things that I showed here are starting to show what some of those things might be, using things like spatial audio, using haptic input, using really good quality, using adaptation. So some of the AI technologies I talked about near the end, one of the really important ones that were looked at that I didn't get a chance to talk about in this talk, but that's really interesting, is things having to do with, for instance, something that's called meta-learning. And meta-learning is an AI technology that learns how to learn. And the reason why that's important is because this allows you to start training models on much, much smaller amounts of data. And this allows you to personalize your models much more effectively. So rather than having to create an AI model that is dependent on thousands and thousands of exemplar elements, say if you're doing computer vision, something like that, instead, I could train a model based on a handful, and it would be my things. You could also imagine how this applies to personal movement. Like, I want to be able to make this individual for you. And so that's another example of a technology that then applies into this inclusion space.
Yeah, that's nice.
Did that answer your question?
It does, yes. And when you talk about individual data and that sort of stuff, it also reminds me of universal design. So that's really good.
Thank you. Jackson, would you like to ask your question?
Yes, thank you so much, and fantastic talk. It was awesome to see these technologies kind of coming to life. I had a question regarding the technological infrastructure that would be your ideal for deploying these devices. So, for example, you showed the video of the young student walking around. Forgive me, I forgot their name, but I was wondering, if you deploy these devices, is there an ideal technological infrastructure you would want, for example, in terms of internet connection, or does the device have an internal memory when you use the Peoplelens, like an OrCam or what have you? I know that's a kind of all over the place question, but I was wondering if there was like an ideal user scenario.
Well, the ideal is everything. Like, give me all the things, and as much power as possible, as much memory, all of that kind of stuff. But realistically, one of the things that was important with Peoplelens was really making as much of the compute as possible local, to be able to have those models be on the device, and that solves a whole lot of problems for us, especially from an ethics perspective and from a privacy perspective. If the identity models and all that kind of information are local to the device, then there's much less chance for those things to be abused by any central, by anybody who's able to hack that central group, or by the central group itself. Like, if you don't trust Microsoft or Meta or anybody else to actually use your data responsibly, better off to actually keep all that information on a small machine that you keep with you. And so with the Peoplelens, that's actually what we do. It's actually all there in local area. Now, the problem with that is that right now, at least, some of the compute required in order to do these things is a lot. We're getting better and better, and as technology increases, we'll be able to reduce the footprint that requires. But I do see that as being something that we see going forward. One of the things for at least Peoplelens, and I think this is true, especially for technologies for blind and low vision folks, that I think is important, is the ability to do things like face recognition and identity. And this is a really interesting problem, because in the EU right now, and also within a number of states, people are looking at foreclosing the ability to be able to do facial recognition at all. And the tension here is, well, do we throw the baby out with the bathwater? Is the threat for potential exploitation of this information so high that we then want to remove the benefit that it provides to this large class of people, and a very real benefit that allows for inclusion for people that are blind or low vision? And that's a tension that we have to make societally. That's not something that we can do at a technical level. And I think that one of the things that we've been doing with the EU, for instance, is having that conversation at a policy level of, can we start to have a conversation with the ministers there to say, there is a need and a benefit that you may be completely foreclosing if you make this, if you remove the capabilities entirely. And so then the question is, well, how do we put the right guardrails around that so that we can actually enable it effectively? I realize that went well beyond your question, Jackson, about my ideal technical infrastructure, but I think that it speaks to that a little bit.
No, you actually improved my question a great deal. My only other question was, immediately when I saw the video, I thought of assistive technology training centers where users go to kind of learn about the devices that they're going to be using to accomplish certain tasks. Is there a part of the process where you train the user, or is the system designed to basically train the user for you?
Different different devices, different things. So the Peoplelens is still an experimental device. Like this is not available for sale right now. We've built a number of these and we're deploying them for testing among children. We've got, I think, maybe 12 or 20 children that we're going to be working with in the UK that are blind and low vision. And for that device and that experience, we've actually built out a good deal of a scheme of work and a curriculum for using it effectively. So there, we've got a lot of that scaffolding built in because we think that's really important in that case. For some of these other technologies, for instance, Seeing AI or Soundscape, we don't have that curriculum in place, but they are often used by, for instance, orientation mobility instructors, different places that are assistants for blind or low vision folks. They will use these things individually to help individual clients as they think is appropriate. And we have been reaching out much more recently to O&M instructors, especially with Soundscape. And then there's another project we're working on that's more general about tech use and how to get. The thing is that O&M instructors, orientation mobility instructors, tend to be very conservative. And historically, they've aligned themselves with no tech. Like, you need to be able to use a cane or your dog, and you need to be able to get around and don't depend on any technologies. That is starting to change with some of the newer generations of O&M instructors and professionals. And so those folks now are more willing to maybe use and integrate some of these technologies into it. But we're also trying to just create some ways by which they can do that effectively. And that's an ongoing process. And we're still working on that.
Thank you, sir. I appreciate it.
Mm-hmm.
We're just past 3 o'clock here. Dr. Cutrell, do you have time to answer 1 or 2 more questions from the chat?
I'm fine to do that, sure.
Sure. One mentions the WCAG3 guidelines that helps developers of websites and mobile applications with accessibility, and asks, is there any organization like W3C for AR and VR technologies that app developers for AR and VR can use? So
the answer to that is there's not one associated with anything that's as big as W3C or WCAG. Like, that is very well established, and they're a standards body effectively. Right now, there is no standards body for VR, AR. It just doesn't exist. The closest I would come is something that's called XR Access, and this is a consortium of academics and companies that are coming together to try to really hash out some of this stuff. And so I would just do a quick web search for XR Access, all one word, and you'll see that there. They do. There's actually a number of events they hold. They do, I think, every couple of months they'll do some talks and things like that. So they've got a number of resources there you can look at as well.
Great. And then Sharon is asking, she mentions it would be great to hear more about the privacy response you're talking about and keeping data local. And Sharon, feel free to chime in.
Sure. If you want to talk a little bit more about that, I'm happy to respond.
Sure. I think your talk was terrific at establishing the huge benefits for many people associated with these technologies. I think if folks from the ACLU or the Electronic Frontier Foundation heard this, they would be quite alarmed as well at some of the technologies. And you were beginning to address where we might go from a policy standpoint in order to control what one discloses about oneself in different environments. And I just was interested in hearing a little bit more about that from you.
Well, I mean, the first thing is that it is the case that this is thorny. Like, there are no easy answers here. And as with any technology, you know, technologies are not value neutral, but nor do they have specifically values. I mean, it's really has to do with how they're used and how society enables them to be used. And so, you know, a lot of the work that we did with this was first off to understand what some of the people that we were working with, what their needs were, what really helped them to be effective in enabling them access to the world around them. And then we want to sort of backtrack out of that to say, well, how do we provide them with some of this access without unduly creating harms on anyone else, or you know, how do we mitigate those harms? And some of the early ways we thought about doing that, and I want to point out this notion about the social piece, is that we already have some of those things in place with just the way we interact with each other. And if we say that this is completely a technical problem, then I think we miss some of the point about the fact that we already negotiate this all the time. It is the case that we interact with people, and you know, we have a public world in which we see other people, and we know that I see somebody across the room that I don't want to talk to. I just, you know, put my head down and I move across the room so that I can't be seen. And so that's why we created, for instance, this feedback element, so that it gave you information. There was some transparency about what the technology is doing. Now, you know, some people may view that as, well, how is that any different from a stupid little red light on a camera, just saying the camera's on? Now, that doesn't really help me to know that the camera's on. I still don't know what's being done with the image. I don't know how it's being stored. I don't know where it's going, all those kinds of things. And those are legitimate questions and they're legitimate concerns. But I feel like we have to start somewhere in there to start talking about, well, given these benefits, how can we start to mitigate some of those concerns? I think one way is to talk about keeping data local, as you mentioned there. That's kind of an easy one to think about. But I think there are other ways as well, which is, you know, instead of requiring things like informed consent, which I view as this very heavy-handed, clumsy way of interacting, there may be other ways of managing that kind of consent. Maybe that there is a level of information that you're able to get about people around you that doesn't require that kind of informed consent. But that if you want additional information, like, oh, a name, or if I want to store your face in my system for any substantial period of time, well, I need to actually get your permission to do that. And then we provide maybe a good experience for that doesn't provide a lot of stigma associated with it. Well, I'm blind, I need to ask you this question, which everybody else gets just by virtue of the fact that they can see you. But now I need to ask for your permission so that I can actually remember you. And I don't have a good solution for you, but I think that these are the kinds of questions we need to start raising in order to actually get to a good solution. Is that helpful?
Thank you so much again, Dr. Cutrell. This has been wonderful, and we appreciate everyone taking time to tune in and learn with us this afternoon. The recording will be available at goodsystems.utexas.edu. And we invite you to learn more about Good Systems work and future programs, including our upcoming annual symposium on April 7th and 8th, also at goodsystems.utexas.edu. Thanks, everyone.
Thank you all. This is a real pleasure.